All right, let's get started. Thank you everybody for joining. My name's Josh Gross. We're going to get started talking about building agentic AI systems, what we've learned here at Resolve, as well as with some esteemed guests. So let's dive in. Now, to do this topic justice, we needed a pretty broad set of experiences. And so we've got our CTO, Mayank here, Kent from Yelp, who's led engineering teams both on developer experience as well as product. Divya, who's leading teams at ThoughtSpot, as well as Gabor, an AI engineer with extensive experience in AI. But before we jump in, since this is a little bit about our journey too, in terms of building agentic systems, we're going to talk about what AI for software engineering or production engineering really looks like. So let's give a quick background of ResolveAI. So this company, this is my second time actually working with Mayank and Spiros, our founders. Interestingly enough, this is my first startup in AI, but we've been doing this for about 2 years. And we've received quite a bit of, I would say, support along the way. And the reason being is because Mayank and Spiros have been dealing with this problem or trying to solve this problem for quite a while. So previously, you started companies within monitoring, so logging, distributed tracing, co-created open telemetry, ran Splunk observability at Splunk post-acquisition. We've got great support from Greylock, Unusual, lots of names within AI. But I think the thing that's most telling here for me, having built companies previously in a SaaS generation, is the amount of talent it takes in building AI systems for complex, say, work, I would say processes and tasks. And so the team, since I joined, I'd say April of last year, we're about 6 folks. We had all the domain expertise in running like large production systems, both in building monitoring tools and operating them. But AI was so native at the time that, or was so nascent at the time, that we really need to build all the foundational scaffolding as well. And so today we're a little over 50 employees, a lot of great talent, folks that built Canvas, deep research at DeepMind, so Google DeepMind. We've got folks that built the algorithms at TikTok to increase engagement by 2% at scale. It's a really amazing team, and hopefully you'll see why we've needed that as we talk through how we built Resolve. So in our journey in building Resolve, just like many startups, you have to identify companies that, one, have the pain that you're trying to solve, which is running complex production systems or growing very, very quickly, trying to introduce new features without being weighed down by technical debt and operational overhead. And so early on, we started working with companies like DataStax, an amazing high scale, high SLA company focused on NoSQL workloads. Uni, a fast rising digital bank or neobank in India. Blueground, a competitor to Airbnb and long-term stays. Rappi, the Instacart, DoorDash of Latin America. Tubi, a company that had, I think, over 15 million viewers of the Super Bowl just this last February. And really, the challenges are all the same. There's one side of it where it's about incident response and lowering your, say, MTTR, really downtime or impact to users. The other, which has emerged, is developer productivity. And we've seen that a lot on the code gen side, but we'll see how investigations, triage, all of that impact individual engineers as they try and produce great new code innovation. Now, in dealing with this problem of, say, you're on call, an alert fires, you're trying to figure out the impact. When you think about what a staff level engineer that has, say, 4, 5, 6 years experience at your company does, is they go into this bank of knowledge that they have. So all this context, this tribal knowledge, understanding, okay, yeah, we had this limit set for some reason, or this timeout, or this circuit breaker. They know that this service, although there's not a direct connection, it actually depends on this other service as well. These are some of the challenges in, say, dealing with incidents or dealing with availability is you have to have all that tribal knowledge or that context that a senior engineer would have. And that's why you have the escalation paths to those principal staff level engineers. Well, with AI, that data isn't actually accessible via anything written down. You may have run books, you may have, say, postmortems, but that data lives on problems that have already been solved. And so one of the big challenges in building a system that can operate like an experienced human in debugging issues is to create that knowledge both organically via, say, integrations or creating what's called a knowledge graph, so a dependency map or a topology of your environment, as well as understanding how individuals might navigate across this environment. So one of the core tenets of Resolve that makes our investigations work so well is the production of what we call a knowledge graph, a graph database that helps us to understand the relationships. When you think about large production services, one of the biggest issues is event correlation. There's so much change that occurs in these environments. So how do you make sure that you understand the causality behind those changes or the relationships? The next thing that happens is when you think about the last time you were on call or you were brought into an incident, the first thing you do is you start with, say, a dashboard or a hypothesis. That dashboard, you start to look for anomalies in specific charts, and then you might go to a log query. And so you do all these things sequentially based on insights and knowledge that you might have, and then you're going into the various tools to get there. Well, because of the sequential steps and these biases that individuals have, it makes making those, I would say, on-call processes very difficult to predict based on who's on call and the experience that they have. And so one of the things that we had to think through was how do we use ranking? How do we use eval sets? How do we make sure that the task that the agent takes and what it does with the information or the evidence it gathers, we can actually multi-step or kind of navigate across a complex environment to get to causality. And finally, even though we worked at Splunk and we had all access to all of the observability data you'd want, so we had your metrics, your logs, your traces, we had your real user mining, your profiling, your network, your synthetics. Um, what happened there was we realized that even when you have all that data, it still takes a human with context to be able to navigate and operate those tools. The challenge is, and I think Gabor may get into this during his portion, is that when we talk about AI, it does feel like magic, but it's not magic in that you need access to the same tools or the systems that humans would need to troubleshoot issues. And so one of the ways that we accomplish that is we realize that, okay, most engineers, if you follow them during a postmortem or during an active incident, they're going across multiple tools. And so what we needed to do was figure out how do we integrate with these tools and use the context and understand the context of those. And now that's even evolving into accessing via MCP servers or custom tooling. How do we use that just like a human would? And so when we put this all together, the knowledge graph, the reasoning capabilities, do a multi-step process and iterate alongside this agentic AI, and the access to the tools, you get a comprehensive understanding of I can troubleshoot just about anything. And what we've seen emerge from this is not only incidents, so you think your P1s, 2s, 3s, and our ability to, say, have an autonomous or a background agent that can troubleshoot, but you also start to think about, well, what about all those times that engineers are blocked because they're receiving 503s from a gateway, or they're seeing latency, they're going to an engineering support channel, or they are escalating to a platform team. What if we could create an interface as well so that you can unblock all of those? And that's when you start to unlock the developer productivity side. So now I'd like to hand it off to Mayank, our CTO, who's going to talk a little bit more about what we've learned in building agentic systems with AI.
Thank you, Josh. Hi, everyone. My name is Mayank Agrawal. I'm one of the founders and CTO at Resolve. And as I was telling Josh before this call, that partly by luck and partly by design, I have been both building and working on developer tooling and monitoring systems all of my career. Before Resolve, I was at Splunk. I was one of the architects for all of our observability products, that Splunk shipped. I led many initiatives at Splunk to improve the reliability of our systems, developer productivity, other, operational initiatives. Joined Splunk through the acquisition of our previous startup, Omnition, where I worked with Josh, Spiros, and few others from our team. We built a distributed tracing-based monitoring product also helped create OpenTelemetry, which is a very popular open source project to help you instrument and route telemetry data to your choice of monitoring vendor. And through my career, both kind of built in-house tools and monitoring systems, and also shipped customer-facing capabilities. Um, left Splunk, I guess, along with a bunch of other people, when Gen AI, advances happened, to rethink how we kind of, build software, operate software, and excited to share, a few of the lessons we have had about building, agentic AI for software engineering. Um, um, uh, on the next slide, please. Yeah, but before we talk about what it takes to build agentic AI for software engineering, let's step back and kind of appreciate the time we live in, and the impact that AI is having on our lives, not just on software engineering, but overall. The way we consume software even has changed a lot. We expect software to be a lot more smarter than previous generation. We expect it to act like a human, and kind of work with other systems much more seamlessly. And that is reflected by the way we consume chat gpt to design software, and to think about our choices, and to even solve daily problems. And we've been through many technology shifts before, kind of cloud computing, microservices, DevOps, to name a few. But I truly believe that the way Gen AI is shaping software, both how we're consuming it and building it, is like no other technology shift that at least I have seen in my career. And the way we create software has also changed a lot. We started by consuming tools like GitHub Copilot as a smart autocomplete kind of a tool. But over the last year, even we have evolved to kind of building out pull requests based on a prompt, and offloading a lot more work to agentic software or code creation tools like Cursor and Windsurf and Claude Code. Just to give an example, at our team itself, more than half of the code is now being created through vibe coding, right? Of course, there's a lot of checks and balances that have to go into place to ensure that it's very high quality and operates properly. But the gains, the productivity gains, are just undeniable of AI, and I think we are just at the start of this revolution. So if we look 2 or 3 years ahead, what can we predict about what will happen with AI in terms of software engineering? And I really think we are just at the start of this trend. Models are just getting smarter. We're starting to build out more and more sophisticated agents, and I think that we are still at the beginning of realizing the productivity gains from AI. So I think in the next few years, AI will just uh, explode in usage, dramatically increase our productivity. And I really think that the next step function here is going to be agents that are just working with each other, that are very, very knowledgeable about a specific task, or about a specific domain, and they are going to collaborate with each other to offload more and more amounts of work from humans, and allow us software engineers, and in general humans, to be really up leveled and democratize software engineering. I think more and more people will be able to create code, and ship features to production, and code will be different. The current way that we write code and operate production will become more like a middleware, right? And this is already happening. We are expressing more and more software in natural language, and we are consuming software through natural language. And I think that makes software much more accessible to everyone. And to me, this is a very good thing, right? It's not like our jobs are being taken away, but we are able to accomplish a lot more now. And I think there is so much more need for software in society, and I'm very excited for what's in front of us. Um, so have operated large scale production systems for many years. And in my model, in my kind of mental model, the code creation is a very small part of software engineering, and our vision is that all of software engineering will be automated with AI. When I was at Splunk, team of several hundred engineers, um, what I noticed is as our teams grew larger and the amount of complexity of software increased that comprise our web applications, the amount of time that engineers spent writing code, actually shrank a lot. We had change freezes during holiday periods and during critical times like Black Friday and Amazon Prime Day and so on. We introduced a lot of processes that created a lot of friction to shipping software for good reason, right? We didn't want software to go down. Software was creating a lot of value. Activities like compliance audits or incident postmortems or incident firefighting, they started taking a increasing amount of time from our engineers whose core job was actually to ship new features to production. And so I think with AI, you also need a balanced approach. Tools like Cursor and Claude, are helping us create a lot more code much faster. But the reality is we are also, not going that deep into that code. We don't have a deep operational understanding. So create the to keep the balance and, to even allow us to ship more code faster, we need code to be very high quality, to be easily debuggable. And I feel that, it's not just, code creation tools. We need a whole family of tools that will help us, maintain this code up and running with high degree of efficiency, operational excellence, and I think that's kind of the big piece that's missing right now. That's what we have been working on, and a bunch of other companies in this domain. And I think that's those are some of the very hard problems that need to be solved very well to truly accelerate software engineering with AI. Um, so, maybe we can talk a bit about, what it takes to build, agentic AI that can help you automate software engineering and, especially operational tasks. So, before we talk about that, we need to recognize that to keep software operational, humans use a lot of different tools, right? It's not just your, code, which of course is a very important ingredient into, operations, but people use monitoring tools. Sometimes logs, metrics, traces go to different tools, or even multiple tools. Like some of your logs might go to CloudWatch, some logs might go into Splunk. You have your CI/CD tools, which have information about what changes have happened in production. You of course have your chat tool like a Slack, where a lot of human collaboration happens. You have your runbooks, and there is a lot of tribal knowledge that's not even written down anywhere. And for software to be operational and to keep on providing value, humans operate a lot of these tools across multiple operational boundaries. So you might have multiple on-call rotations as well. And in order to automate the work that humans perform currently, um, to keep the software operational, you need an agentic AI that can continue to operate these tools like a human. And there's a lot that goes into building a tool that, or building an agent that can accomplish that. You need a deep understanding of your production systems, about the topology of your environment, what kind of code repositories are contributing to a production artifact, how things depend upon each other, and where even telemetry data lives for any particular service in my environment. You need agents that can reason about the systems like a seasoned engineer, that has deep tribal knowledge about how the system was built, how it operates, operational failures, and how typical recipes to fix them. And then you also need the agents that learn with every interaction, right? So there is a lot of unwritten knowledge that you just built by going through multiple incidents. And so similarly, just the way that a junior engineer gets up to speed by shadowing a senior engineer, you need agents that can learn from every interaction and get smarter and also stay up to date in their knowledge, because these systems are very dynamic. They evolve over time. And in order to do that, you need a lot of skilled talent that can build these kind of sophisticated agents. You need to bring together deep domain expertise and also deep AI expertise. You have to stay at the forefront of what's happening with models. You need to contribute to that, and also in our system we use many different models, because different models are good at different kinds of activities. So it takes a lot to build these kind of agents, and this is kind of one representation of how you might go about building these kind of agents. So if we, uh, you know, just in closing, wanted to share a few learnings that we have had from building, agentic AI for software engineering over the past, couple of years. First of all, I think, for everyone, and for myself included, we are thinking AI first, right? We need to stay competitive. The industry is accelerating the rate at which value is being shaped, and you really need to think how you leverage AI in every aspect of your company. Not just code creation, but how you ship, what kind of software you ship, and how you even operate other functions. AI is giving massive productivity boost, and this is the way to stay competitive in the market. um, and then with vibe coding, there is a kind of a attraction of over a weekend I can just vibe code this feature. But I think there's still we need to be smart and judicious about where we put engineering resources. We need to invest in undifferentiated kind of or in differentiated IP, and not kind of waste our precious time on undifferentiated work that dedicated teams are working on. uh, and finally, you know, in my opinion, a CTO's technical strategy has many different aspects. Of course, where you are investing on, what is your differentiated IP, where you use open source, but also, in my opinion, and these are some of kind of lessons I learned from my past experience at Splunk. Where what kind of vendors you bring in. Are they building the next generation of tools? Do they align with your vision for your technical roadmap? I think that can give you a massive acceleration also in kind of value delivery to production. So with that, I'm going to hand it off to my colleague Gabor, who will share a few more lessons from his experience.
Hi, thanks, Mayank. I'm Gabor. I'm looking at things from the other side of things. An AI engineer here at Resolve, hoping to give you guys a perspective, maybe more from the trenches of what it looks like to actually be building these experiences, or what it at least feels like to build these sorts of experiences. So the main lesson that I think I want to convey is a bit of a contradiction. AI is both magical, but in kind of an ordinary way. So what do I mean by that? I mean, like when I think of magic, I think, Gandalf in the Mines of Moria, you shall not pass. And then off screen, something happens, magic happens, and the Balrog disappears. And I've been fortunate in my career, both at Resolve and previously at Google DeepMind, to get to witness that fight, so to speak, to see what that magic looks like. And it's not that it isn't magical. It's very clear that AI can do things that I would never imagine, even as an AI researcher, AI engineer, would have been possible. But it's doing it in a very ordinary way. And what do I mean by that? I mean that it looks a lot like how the rest of software looks. The fundamental reason for this, I think, is that the capabilities of LLMs are still very much in line with the capabilities of how other AI systems over the past couple of decades have worked. There are things that the engineers and researchers at Google and OpenAI and Anthropic care about and put into their data sets, and there are things that they don't. And so these AIs work better at the things that these companies care about. You can test this yourself. Ask an LLM to write a very complex JavaScript web app, and it'll do a fantastic job. Ask it to go to Java, and it'll do an okay job. Ask it to go write, Fortran, and I mean, it'll do something, because they are generalizable. But it's not like no one at OpenAI cares about how good Fortran coding capabilities are for these models. And what that means in practice is that as an AI engineer, I spend most of my time projecting the capabilities of the model onto the task that we're actually doing. And this is a very ordinary sort of thing that we do all the time in software, where we have, the capabilities of a programming language that we project onto the task that we're trying to solve. And it has the same sorts of complexities to actually launching and rolling out in production. You have to build the code. And in the same way, you have to build the data set or build the prompt for the AI system. And much like code, what do? You write something, you run it a few times, you see if it works. Invariably, when you show it to other people, they use it in some new way. They ask new things, they send different data through it. And you have to play this game of whack-a-mole of, fixing the code to make sure it works for all of the inputs. Similarly, even prompt engineering and certainly data set collection, you have to, you roll it out or show it to some people, they ask all sorts of stuff you don't expect, and you have to adapt the system. You have to build out this system to handle that range of outputs, which leads naturally to, how do we do this in code? We write unit tests. The equivalent of unit tests in AI systems is evals. Helps the whack-a-mole somewhat in the same way that unit tests help you have certainty that when you make a change in code, you didn't break everything that came before. But even there, like unit tests, when you run the code, it does the same thing every time. LLMs, not so much the case. So you get a number, but it's not necessarily telling you, hey, here's precisely what went wrong and how you're likely to fix it. And then the last thing that, of course, we know from software engineering is actually maintaining things that are out in the wild has a maintenance burden. LLMs, this actually kind of surprised me when I started properly rolling out LLM applications. But even for prompted applications, this is true. And like one side of this is more clear, bug reports come in that want new capabilities. You have to adapt the system and continue to improve. But even if it's just in pure maintenance mode, eventually the models deprecate. Eventually you have to move from one model to a new model. And it turns out that prompts certainly, translate to some degree, but not perfectly. And data sets similarly, depending on what model you start from, you'll have oftentimes substantially different characteristics when you retrain it on a new base. So what am I trying to get at here? I think oftentimes we view LLMs as like a way to magically get around the difficulty of building a complex piece of software. Or, we only look at the complexity from LLMs from the perspective, like, how do we actually tie together all these APIs and build the system? And I think this is a fallacy. It turns out that there are a bunch of things that make the building and maintenance of AI systems, and especially as you compose them into these sort of larger and larger agentic AI systems, that require a substantial amount of burden, not to prototype, but to like actually roll out into production. All right, so the other side of this is it's been a very negative talk so far of like, hey, AI is very hard, which is true in some ways, but like so is software. Clearly, the answer is not to never build software. We're all software engineers here, or at least in the software industry. And in the same way, clearly, it's not the case that you should never build your own AI system. You should never build your own agentic system. The big question is, where is it going to provide the most value? Where should you actually be building it? And for this part, I'm actually going to take off my AI engineer hat and put on just like my regular software engineering manager hat. The way I think about this is I treat AI very similar to how I treat regular software engineering. When do I build versus buy something in some product that I'm building? Well, a good litmus test in my mind is to think about whether I'm describing this thing that I'm building as a component of the system or as an obstacle that I have to overcome to launch it. So components are things that my team is good at, or I'm good at if I'm building it. Components are things that bring differentiated value to the product. Components are things that our engineers want to build. This is a thing that they'd be happy to build and maintain. Obstacles are everything else. And there's a bunch of obstacles, a bunch of things that are not core, but maybe either flourishes or more commonly just a thing that has to be there for the product to work, but can be more commodity. And just to make things concrete, I'm actually going to go back one step further in my career to Square, where I led an AI team and actually the infra team that was building Square Messages, a two-way communication platform between buyers and sellers within the Square ecosystem. And the AI side of the team around 2020, 2021 or so started looking seriously into LLMs and how we can bring AI and these suggested replies to this messaging system. And so this is a bit of a contrast of things that I think we should have bought and things that I think we were right to have built. This is a case where actually I think we were right to have built the AI. Like at the time, GPT-3 was the best system that was available, openly. And we made the decision deliberately to make our own, to fine-tune our own, at the time, GPT-2 model. So it's even a smaller model that we could build internally. The reasoning here, A, we had a dedicated AI team that could do it. B, we had a whole bunch of data that gave us a competitive edge in building it ourselves versus just prompting a system. And C, it was a thing that was important for the product. Like regularly, we heard the feedback that sellers wanted to sound more professional. They wanted to sound like it came in their tone, or at least a tone that was customer support ease, so to speak. And this is something that we can get much more reliably if we, throw a whole bunch of data at it and train a custom model, as opposed to trying to finagle a public system to do the same. And it was an important feature of the product. This was one of the main selling points and main driving points of why people would come to Square and Square Messages to get. By contrast, and this is a classic mistake, I can, I can say I was younger and more naive. But at the time, we also hosted our own models. We had GPU nodes on Kubernetes, and we had a service that we booted up. And the assumption was like, oh, it's not hard. Like Kubernetes is there. How hard is it to just like run a main method and some PyTorch code? And like that was almost certainly a mistake. We spent a whole bunch of AI engineering time on maintaining the system that just didn't need to be maintained for the product to work. It was very commodity to have somewhere that serves a PyTorch model. And then we could have put the logic into our main service rather than this AI service that was backed by a backend team that had all of its infrastructure already around it. And so, there's an example of this contrast between components, the actual main model that was that formed the backbone of Square's AI, or Square Messages' AI product, versus an obstacle. We have to host the model somewhere that probably we should have just used something commodity. And so for final thoughts, maybe I'll try to put myself in the shoes of somebody building these systems, which I guess I am at Resolve, and advice to leadership. So maybe I'm indirectly talking to Mayank or something here. But a couple of points that I think are important takeaways. I mean, one which we've touched on a couple of times here is to put engineers on mission critical stuff, not on things that, even if they're exciting, are fundamentally, just obstacles that are relatively commodity. Similar to that, keeping in mind that AI systems have a testing and maintenance cost. The building cost is also there, but I think that one's better understood. Testing, that is making evals for these systems, and maintenance, that is keeping the prompts and the data sets fresh over time, I think are much less understood in the zeitgeist of agentic development. A natural conclusion of this, putting more energy into fewer AI applications. This is a big theme at Google, that everyone was complaining that like AI is being spread everywhere. And I think it's kind of right that it would have, it's a better idea to pick a few places where it makes a big impact, where it's a differentiator to the product. And where as an engineer, I can put the effort that I want to put into to make it great, rather than trying to rely on this generalizable purported magic of AI to work for everything everywhere all at once. And almost in contradiction to that, also letting us hack. I think from like putting on my eng manager hat, the reasoning here is it gives you a good sense of what is feasible and what is not, and what are the places that you should be putting energy into, rather than like fully staffing all these projects. First, go let people do it in 20% time, or AI hack days or whatever, and then pick the few. And the other, just greedily, they're fun to build. The anecdotes I'll give, both from Google. One of my friends there was the tech lead for Gemini Canvas, and he just has a blast, vibe coding AI applications on Canvas that call the Gemini API, and complains regularly when a new model comes out and he has to update the prompts and the systems for Canvas to adapt to this new model, in the next week when the old one will get deprecated. Similarly, I worked on a project at a hack day at Google that was a blast to work on. Spent a week hacking it out. And then it took months thereafter to get it to a state where like it's actually ready for launch. And so I think the separation is both fun and healthy for at least me as an engineer, and I don't think I'm alone here. And with that, I'm going to finish up my take and hand it back to Josh.
Thank you, Gabor. Those are some great insights, first from Mayank, in terms of the speed in which AI is evolving and depending on the use case or the workflow that you're trying to solve for, the amount of intention and I would say architecture that needs to go into it. With Gabor, you see the trade-offs, some of the mistakes that are made. Interestingly, and before we get into folks that are outside the Resolve building, so you can see some real-world experience in making these decisions. Earlier in my career, I got the opportunity to talk to an executive at Netflix because at that time they were releasing so many open source projects. And I was like, well, how do you decide on this build versus buy or when you're going to allocate engineers' times to creating something and then open sourcing it? And their response was like, of course, them being heavy on AWS, I would imagine they're the ones that helped coin the undifferentiated heavy lifting. But for them, it was more around, is this a problem that one is critical to our business functioning, but two, that nobody else has actually solved yet? And if so, the decision is already made. And so now I want to talk to Divya as well as Kent to understand how they're making these decisions in their organizations. And so first off, this build versus buy debate. When you're looking at, say, making a technology decision or allocating like, engineering resources or headcount, how do you decide on build versus buy? And Divya, maybe you want to start.
Thank you, Josh. Um, Let me give some context about my team. I'm Director of Engineering at ThoughtSpot. ThoughtSpot offers AI for BI, and my teams build the Mode as a data warehouse, and we joined ThoughtSpot through an acquisition of Mode Analytics. And we build Mode as a data warehouse for ThoughtSpot AI and analytics. In the last 3 years, we have tripled the backend footprint of our services from 4 to 12 homegrown production grade services. And in terms of evaluating whether we use open source or third party or build versus buy, the usual suspects. So what is the desired functionality? What is the cost of ownership? Will this grow with the roadmap of the company? And we move really fast, so innovation and pace is very important, whether we consider a third party or an open source tool.
And Kent, do you want to add anything to how you think about the principles and maybe give an intro as well?
Yeah, sure, Josh. So I currently lead the core consumer experience at Yelp. And prior to that, I spent about 10 years building developer productivity tools internally at Yelp. So I kind of have two different points of view on this. And I think the interesting thing is like early on, we didn't have a lot of tools in the developer productivity space. So I think similar to what you said before, Josh, if the tool isn't really out there, then we're going to end up building it if we need to solve a problem within our company. The interesting thing today is there's a proliferation of tools in the space. And then also as I move into the consumer space, I may not want to get into building out some of the things that are maybe more internal operations for the business. I might be wanting to focus on building towards our external consumer product. And so I think a lot of kind of what you all have said already resonates in that space. Like, am I building out my core competency, or am I, or is this something that I'm okay to defer?
Yeah, that makes a lot of sense. And I actually want to double click on that. Divya, one of the things you said is you've tackled a lot of these projects, and it seems like you have a pretty strong principled way of approaching it. Usually when I think of build versus buy, I also think of like speed, performance, customization. Like, are there any learnings, maybe good learnings and bad, similar to how Gabor explain some of the mistakes that they made or the learnings as well that you can share in terms of your experience in some of these more recent projects?
Absolutely. Um, so I'll actually share an experience of a case where building worked for us, and it actually brought unexpected benefits.
Yeah.
We were using a third-party, pretty popular managed service for powering the schema browser for SQL queries. And as we added more customers and added AI capabilities, we started hitting hard limits. And the only way out was throwing more money at it. And this was already the third most expensive tool in our portfolio. So we decided to build in-house. So we shipped a service in 6 months at 1/10 the cost, at 8x faster response times. And the scale was pretty high. The largest data source index was around 150 million columns. So the ROI was pretty high in building in this case.
Yeah.
But to do the same as an agentic solution for platform services poses new challenges, and I'm watching the space very closely.
Yeah. It is fascinating. I think that that's a great segue into like the differences in the equation. So Mayank mentioned the velocity in which AI is evolving. I was talking to, so in our product, we now, when we root cause something, we can actually go and call Cursor to produce a PR, which if you would have asked me 6 months ago, if we were going to get that, I would have thought it would have taken 2 years. Like, yes, of course, that's what we all want, but is the technology there, both with our accuracy on root causes, but also Cursor's accuracy on throwing in a PR? And so it's mind blowing how quickly things are accelerating, in fact. And even with when I talked to engineering execs last summer, it was all about like, hey, let's adopt AI for these very typical, say, Gen AI use cases like summarization or thinking through tasks that take a little bit of time. They're annoying. Let's eliminate those. When you think about like the build versus buy with AI, knowing how much innovation is happening, and what the perceptions of each engineers may have on those spaces, like how do you think about just AI and build versus buy and when to innovate with a vendor or alongside a vendor versus internally? And Divya, if you want to take that first, and then I'd love to hear Kent, your perspective as well.
So I actually look at it twofold. So one is innovation in the application,
Mm-hmm.
and the process innovation, or where it's not too much of a differentiator for a given organization. In
Yeah.
our team, developers own QE, ops, incident response. So I'm particularly
Mm-hmm.
excited about AI first services as software for incident
Yeah.
response and help desk, customer support, for transforming the way we work. But when it comes to the application itself, I think true innovation lies in the diffs, diffs of
Yeah.
code, of data, of workflows. So there I do see that the investment is important to be able to tinker with AI tools, to learn how to partner with other builders and other agents, how do we customize off-the-shelf tools. So I do think that the build muscle also needs to be nurtured along with adopting the cutting edge third-party tools.
Yeah. Kent, what do you think? I'm curious on your perspective on building in-house AI versus going and tinkering with off the shelf or putting a strategy around it.
Yeah, it's pretty tricky, and I think we'll talk about like some of the complexities around building with AI. I think like first off, the way we started this conversation is like, how do we think about build versus buy? And I think we need to think about what problems are we solving, and then that's kind of guiding how we're adopting solutions. I kind of view AI as just a way of accelerating solving those problems in house. And so then, okay, if we look at this as an accelerator, the question is like, how much are we already invested in that space? How much competency do we have around building with AI in that space? And just even, when I think about my developer productivity group, there wasn't a huge skill set around working with AI. And, you know, in the past, it might have been more math intensive. Today, it might be a little bit more approachable because you go, oh, I just need to add some text to modify a prompt, but it's actually way more complicated than that. And I think you start to realize this as you're building out tools. So I think we are really interested in seeing, like, can we replace different portions of some of the things we've built in the past as like one opportunity to simplify our maintenance costs. And then we're also like careful of not having 1,000 different tools, you know, as there's the proliferation of SaaS tools out in the space. And so like, where are we kind of picking and choosing where we're adopting that tooling?
Yeah, yeah, and I feel like we've seen this reemergence of hackathons. The Gabor mentioned he's like, I'm not signing with Resolve if I don't get my 20%, you know, to hack. It is fascinating in this space. There was an A16Z article yesterday. It wasn't like anything new if you've been in this space long enough around like the delta between a demo and actually taking an AI or an agent into production. Clearly, it depends on the scope of the work. Are you replacing a true workflow? Like for us, we think of like reliability. Okay, how do we approach reliability today versus what could be versus just writing a postmortem or something on a Slack thread, you know? I'm curious from your perspective, and Divya, maybe you want to go first, is when you think about like one, enabling your engineers to do demos or create hackathons, but then also like how do you think about, okay, we want to allow our engineers to develop this muscle like Kent mentioned, but how do we know when to actually drive those into production or not?
So as I shared, our team is seasoned
Yeah.
with rolling out production services, and we have been able to do it consistently with zero customer downtime. When we built the AI assistant for SQL IDE, we managed to ship that within 3 months. But this project broke all the rules because the real work actually started after we shipped.
Yeah.
We found that without any changes in code, we would see a regression. If there were new models that we needed to evaluate, that posed a challenge. How do you really come up with a benchmark for a golden data set for a user-written query, and be able to use that consistently for CI/CD and A/B testing? So with AI, that's been the challenge, that if when we're building ourselves, it's easy to come up with the prototype and the MVP, but when we start talking about production scale and the myriad use cases that people throw at it, that introduces a lot of challenges, and it's not an easy problem.
Yeah, yeah. And Kent, you had made some comments previously around that even if you have a great, say, MVP, you have to be able to give a pretty strong litmus test to know, will this be as valuable as you think it will, and what's the delta between this and in production? Like, how do you evaluate or think about these AI hackathon projects, these MVPs, versus if they should be supported to go into production or not?
Yeah, I think you know what Divya was mentioning is pretty common too, like where you have something, and we talked about this in the past where we were describing AI as magic as well. It feels like it's magical when it does the thing that you expect it to do, especially in a hackathon, you know, setting where you're testing it against a couple of examples, everything is working great, and you're like, yes, this is, you know, maybe it's not that hard to roll this out. And then I think reality starts hitting when you're putting it in production, or you know, that this is the challenge, is like, if you're not doing this routinely, then there's like a bunch of steps that typical teams would do before you get into production, like you were mentioning, Josh. Like maybe you're creating your evals first, your unit tests for the prompt that you're creating, and so maybe that's step one to validate that your agent can handle a variety of use cases. But even then, if you're going into production with millions of users, you're going to get surprised by some of the use cases there. And maybe you have constraints for your product where you don't, I mean, there's the kind of the famous thing, I don't know if it was Ford or another company that there's customer support agent and like people asking for free
Chevy.
cars and, like, oh, Chevy, okay. Yeah. And so like, there's all of these like additional risks that you may not even be thinking about because of the non-deterministic nature of how these LLMs are working, and there's a whole skill set to build around this that's not straightforward. Yeah.
Yeah, it is interesting. Like historically, a lot of it's always been functional tests, but that testing has changed so much, and even the user experience. I remember whenever I'd be talking to companies about build versus buy from a vendor side, uh, the last thing they thought about was user experience. And that's always because it's like that's not the strength that they have. And we're all developing new strengths in AI. I'm curious, like when you do put AI into production, one thing that I've seen is in meeting with, so last summer in meeting with engineering leaders, the value of, say, a GitHub Copilot, and yes, that was the leader by far at that time, was it increased the lines of code that you would write. And that's how they were measuring success. And we're like, and I like looked back and I was like, wait a second, that doesn't seem like it's very much tied to value. Today, though, now it's more around like those traditional like PLG or SaaS metrics of DAOs, WOWs, MAUs, and then some qualitative like feedback, which is fascinating because how many business decisions have been made on those metrics alone? And so I'm curious, like from your standpoint, Kent, like how do you think about the ROI of AI tools or how to evaluate that you're getting the value that you're paying for?
Yeah, so I mean, this goes back to what problem am I trying to solve and how am I going to understand how that problem is being solved for me? And so yeah, I mean, I think efficiency and velocity in an organization is notoriously very hard to understand. And so I think that's sometimes where you come up with these maybe output driven metrics that might give you some sense of how things are going. But it's it, it might actually be doing, I mean, historically, lines of code is not a great metric. You can think about it on both sides. More lines of code, not potentially a great thing. Less lines of code, not potentially a great thing if you can't read it, if it affects readability. So yeah, I mean, there's just a lot of pitfalls with just metrics generation in general. But at the end of the day, like if I'm coming to evaluate a product, I'm going to start with like the problem I'm trying to solve. And if I have a problem with, say, on call, maybe I'm just going to start with something super simple, which is, am I improving the lives of my engineers? Like, are they still waking up at 3 in the morning? Am I calling 50 engineers to wake up at 3 in the morning versus do I only have to call a couple of people? Like, how often does that have to happen? And so there's a very easy question that I can ask to all my developers is like, how do you feel about your on-call burden? You know, and that might be a good first litmus test.
Yeah.
Of course, it gets more complicated too when you're starting to figure out whether or not it's worth the spend to get there.
Yeah, definitely. And what we found too is a lot of the metrics around incidents and so forth aren't captured today. And so, yes, the value of eliminating 50 people from a bridge and taking that down to 4, as well as being able to resolve faster, clearly that's important. But if you're not measuring it today, it makes it harder to justify. I know, Divya, from your perspective, when you think about the ROI, and I would actually broaden the question. So for leveraging AI for specific, very well-defined use cases versus larger workflows, like how do you think about the success criteria, or how do you guide your teams to be like open-minded, but also they have to put a business justification forward.
Right. Firstly, I like Ken's approach, in terms of a metric for optimizing sleep for engineers and the effectiveness of that. Um, I do agree that the first principles stay the same. But then AI also brings new dimensions in terms of evaluation. One, I'm concerned about the evaluation fatigue that engineering leaders are going to face because AI tools evolve much faster than SaaS tools, and we have to be prepared to experiment to land on what works for us. And we become a prosumer for AI, so the adaptability, the security aspect of it is going to be really important because we're going to probably purchase something and then customize it with data that we feed into this tool. And does it scale with our use case? That's going to be an important factor as well. And then I know that Mayank had made a reference to this earlier, that the strategic support is also a value add. So where a company or a vendor is providing more than just the technology, would be an important factor in terms of onboarding and figuring out what would be the KPIs for success.
Yeah. Yeah, it's evolving quickly, and I think we've heard quality of life, the KPIs, and also we're helping to define those as well. I know we've only got a short amount of time left, so maybe 30 seconds each. Given that you've all been working with your teams to adopt these new skills, Divya, of course, yours is more senior and they're already doing it as well. But like, what advice would you give to a backend engineer that is looking to say evolve their understanding of AI and participate in this broadening ecosystem and developing these skills? Kent, 30 seconds. What advice would you give?
Well, I think there's a lot of tools out there nowadays. I think deeplearning.ai from Andrew Ng is a great starting point to kind of get started. I think you need to really play around with this stuff, understand foundations, and over time you'll start to see that it's pretty complex as you start working in the space.
All right, Divya.
Um, I have an overarching advice for any organization trying to dabble in AI. AI is blurring traditional roles. And with the experience that we have had in our organization, I think it's important to have an AI advisory group to share learnings and new ways of working with AI and transforming work across the organization, because I think AI is lowering the barrier to try it out. And everyone is coming at it from different angles, and it'll be really good to have everyone learn from each other within the company.
Well, thank you. Thank you, Kent. Thank you, Divya, Gabor, Mayank. Great session today. Learned a lot myself, and I'd encourage you all to engage with us. Of course, we're building a big team to solve a big problem. Would love great talent to join us, but also we're going to be sharing how we're doing it along the way. And so look forward to many more sessions with you all. And thank you very much, and have a great day exploring AI.